There is a place on Earth where every rule of nature seems to bend or break entirely, a continent so alien that it might as well exist on another planet. While every other landmass on Earth follows predictable patterns of life, weather, and geology, Antarctica stands alone as the exception to everything we understand about how continents should behave. Right now, as you watch this video, there's a landmass larger than Europe that defies the fundamental laws governing every other continent on our planet. If mysteries about our own world fascinate you, make sure you hit that subscribe button, because what we're about to reveal about Antarctica will make you question everything you thought you knew about Earth itself. Drop a like if you're ready to explore the most mysterious continent ever discovered, and share this with anyone who thinks they understand our planet, because Antarctica is about to prove them wrong. Antarctica is not just different, it is impossibly different. Every other continent, Africa, Asia, Europe, North America, South America, and Australia share certain fundamental characteristics. They have native human populations that evolved there over millennia. They support complex ecosystems with diverse plant and animal life. They have rivers that flow year-round, forests that grow and change with seasons, soil that supports agriculture. They have archaeological evidence of ancient civilizations, historical records stretching back thousands of years, and a continuous story of human interaction with the land. Antarctica has none of this. Zero permanent human inhabitants, almost no exposed soil, no trees, no agriculture, no ancient ruins, no historical records beyond the last 200 years. It exists in a state of frozen suspension that makes it fundamentally incompatible with human civilization as we know it. But the differences go deeper than just cold temperatures and ice. Antarctica violates rules that every other continent follows. Without exception, consider this simple fact. Every inhabited continent has a name that comes from ancient languages, names given by people who lived there for thousands of years. Africa derives from Latin and Greek terms for the continent. Asia comes from ancient Assyrian or Greek words. Europe has unclear origins but dates back to ancient Greek mythology. The Americas are named after Amerigo Vespucci, but before European contact, indigenous peoples had their own names for these lands going back millennia. Australia comes from Latin meaning southern land, but Aboriginal Australians had been calling it home for 60,000 years before Europeans arrived. But Antarctica? The name was coined in the 1800s, derived from the Greek word Antarcticos, meaning opposite to the Arctic. No ancient civilization named it because no ancient civilization knew it existed. No indigenous people had words for it because no indigenous people ever lived there. It's the only continent with a purely modern name because it's the only continent that remained hidden from humanity until the age of steamships and modern navigation. This absence of human history is our first clue that something is fundamentally wrong with Antarctica. Humans have spread to every habitable corner of Earth. We've crossed oceans in primitive boats, climbed the highest mountains, traversed the deadliest deserts, adapted to Arctic tundra and tropical rainforests. We're an incredibly adaptable species that has colonized environments from sea level to high plateaus, from frozen Siberia to scorching Death Valley. Yet Antarctica, an entire continent, remained completely devoid of human presence until 1820, when a Russian expedition first confirmed sighting the continental landmass. Even then, humans didn't set foot on Antarctica until 1895. Think about that timeline. Humans had already built the pyramids, created vast empires, invented writing, developed philosophy, discovered the Americas, circumnavigated the globe, and started the Industrial Revolution before anyone even touched Antarctica. This continent was the last place on Earth that humans reached, and there's a reason for that. Antarctica doesn't just discourage human habitation, it actively prevents it in ways that suggest this continent is operating under different rules than everywhere else on the planet. The temperature statistics alone are staggering. The coldest temperature ever recorded on Earth was at Vostok Station in Antarctica on July 21, 1983. Minus 89.2 degrees Celsius, that's minus 128.6 degrees Fahrenheit. At that temperature, exposed skin freezes in seconds. Breath turns to ice crystals in the air. Metal becomes brittle and shatters. Fuel turns to gel. Even the air itself feels wrong, so cold it burns your lungs with each breath. But here's what's truly disturbing about this record. Vostok Station is not on the Kyushu coast. It's not in some particularly unfortunate microclimate. It's in the interior of Antarctica, and temperatures that cold are normal there during winter. The average winter temperature across much of interior Antarctica hovers around minus 60 degrees Celsius. This isn't weather. This is an environmental condition so extreme it shouldn't exist on a planet with liquid water oceans and a breathable atmosphere. Every other continent experiences temperature ranges that, while sometimes extreme, fall within bounds that allow for life. Death Valley in North America can reach 57 degrees Celsius in summer. The Sahara Desert regularly exceeds 50 degrees Celsius. These are brutal temperatures, but they're balanced by cooler nights and seasonal variation. Even the Arctic regions of North America, Europe, and Asia, while extremely cold, are nowhere near Antarctic levels. The coldest temperature ever recorded outside Antarctica was minus 67.8 degrees Celsius. In Siberia, that's more than 20 degrees warmer than Vostok's record, and the difference between those 20 degrees is the difference between barely survivable and absolutely lethal. Antarctica exists in a thermal regime that has no equivalent anywhere else on Earth. It's as if someone took a piece of another planet and dropped it onto our world, creating an environmental anomaly that breaks all the rules. The ice sheet covering Antarctica is not like ice anywhere else on Earth. When we think of ice, we think of frozen lakes in winter, icicles hanging from roofs, glaciers and mountain valleys. These are temporary or localized phenomena. Ice that forms, melts, and reforms in cycles. But Antarctic ice is different. It's permanent, ancient, and so massive that it fundamentally alters the physics of the entire continent. The Antarctic ice sheet contains approximately 26.5 million cubic kilometers of ice. To put that in perspective, that's about 90% of all the ice on Earth. If all of it melted, global sea levels would rise by roughly 58 meters. Every coastal city in the world would be underwater. Entire countries would disappear. The map of Earth would be redrawn. But it's not just the quantity of ice that's remarkable. It's the age and behavior of it. Ice cores drilled from the Antarctic ice sheet have retrieved ice that's over 800,000 years old. 800,000 years. That ice was frozen during a time when Earth's climate was dramatically different, when Homo sapiens didn't exist yet, when our distant ancestors were just beginning to use sophisticated stone tools. That ice has remained frozen through multiple ice ages and interglacial periods, through dramatic climate shifts that melted glaciers elsewhere, through global warming events that raised sea levels by meters. Yet Antarctic ice persists, seemingly immune to the climate variations that affect ice everywhere else on the planet. The weight of this ice is so enormous that it has literally crushed Antarctica. The continent sits lower than it should because billions of tons of ice are pressing down on it. If you could somehow remove all the ice instantly, the land beneath would actually spring upward over centuries in a process called isostatic rebound, rising potentially hundreds of meters as the crust adjusts to the sudden absence of weight. Some parts of Antarctica are actually below sea level, not because of natural geology, but because ice has pushed them down. This means Antarctica is not really the shape we think it is. The maps showing Antarctica's coastline are actually showing the edge of the ice sheet, not the true coastline of the land beneath. The real Antarctica, the rocky continent under the ice, is smaller and shaped differently than the frozen fortress we see today. This ice also moves in ways that seem impossible. Antarctic ice sheets flow like incredibly slow rivers, moving from the high interior plateau toward the coast at rates of a few meters per year. This movement is constant and relentless. Ice that falls as snow in the center of Antarctica will eventually, over tens of thousands of years, flow to the coast and break off as icebergs. But the ice doesn't just flow downhill like water would. It deforms under its own weight, creating complex internal structures. Deep within the ice sheet, there are layers that have been compressed, folded, and twisted by the immense pressures. Scientists studying ice cores have found layers that are no longer horizontal, but have been turned vertical or even folded back on themselves. The ice behaves more like a very slow plastic than a solid, flowing and deforming in ways that regular ice doesn't. Then there are the subglacial lakes, and this is where Antarctica crosses from merely unusual into genuinely disturbing territory. Beneath miles of solid ice in complete darkness, cut off from the atmosphere for millions of years, there are lakes. Liquid water lakes. Over 400 of them have been identified so far, ranging from small ponds to massive bodies of water larger than Lake Ontario. The largest, Lake Vostok, is roughly the size of Lake Ontario and lies beneath about 4 kilometers of ice. Think about what this means. The weight of 4 kilometers of ice creates immense pressure. The ice itself is far below freezing, yet somehow liquid water exists down there. The pressure and geothermal heat from Earth's interior combine to keep the water from freezing, creating isolated aquatic ecosystems that have been sealed off from the rest of the planet for potentially millions of years. These lakes are not theoretical. Scientists have drilled into them, and what they found is astonishing. The water is not dead. It contains life. Bacteria and other microorganisms that have evolved in complete isolation from the rest of Earth's biosphere. These organisms live in water that's been cut off from sunlight, fresh air, and new, organic material for millions of years. They've adapted to conditions of extreme pressure, near freezing temperatures, and total darkness. They represent an independent line of evolution, life that diverged from the rest of Earth's organisms millions of years ago and has been following its own path ever since. In effect, Antarctica contains alien ecosystems right here on our planet. Forms of life that evolved under conditions more similar to the ice-covered moons of Jupiter and Saturn than to anywhere else on Earth. Every continent sits within Earth's magnetic field, that invisible shield generated by the churning molten iron in our planet's core. This magnetic field is remarkably consistent across most of Earth's surface. It protects us from solar radiation, guides migrating animals, and allows compasses to work. But in Antarctica, the magnetic field does something it doesn't do anywhere else. It weakens dramatically. The South Atlantic Anomaly, a region where Earth's magnetic field is significantly weaker than normal, extends over Antarctica and the South Atlantic Ocean. In this zone, the magnetic field strength can be up to 30% weaker than the global average. This might not sound significant, but the implications are profound and disturbing. The weakened magnetic field means that Antarctica is exposed to higher levels of cosmic radiation than any other continent. Charged particles from the sun and deep space that would normally be deflected by Earth's magnetic field can penetrate more easily here. Satellites passing through this region experience higher rates of malfunction. Electronics can glitch. Astronauts aboard the International Space Station receive higher radiation doses when passing over this area. And anyone on the ground in Antarctica is exposed to radiation levels noticeably higher than elsewhere on Earth. It's not enough to cause immediate harm, but long-term exposure is a concern for researchers stationed there. Antarctica exists under a weakened shield, partially exposed to the harsh radiation environment of space in a way that no other continent experiences. But the magnetic strangeness of Antarctica goes beyond just a weakened field. The magnetic South Pole, the point where Earth's magnetic field lines are perpendicular to the surface, is not at the geographic South Pole. In fact, it's not even close. The magnetic South Pole is currently located off the coast of Antarctica in the Southern Ocean and moves constantly. It wanders by about 10 to 15 kilometers per year, tracing irregular paths across the southern hemisphere. This movement is far more erratic than the magnetic North Pole's movement. While the magnetic North Pole's wandering is relatively predictable, the magnetic South Pole seems to follow its own rules, jumping around in ways that geophysicists still don't fully understand. Compasses in Antarctica can be wildly unreliable, pointing in directions that make no sense because the magnetic pole is so far from the geographic pole and because local magnetic anomalies in the rocks create additional distortions. There are also magnetic anomalies buried under the ice, massive concentrations of magnetic minerals that create localized distortions in the magnetic field. The Wilkes-Land crater, a massive impact structure buried beneath the ice, creates one such anomaly. This crater is about 500 kilometers in diameter, larger than the asteroid impact that killed the dinosaurs. It's believed to have formed around 250 million years ago during the Permian-Triassic extinction event, the worst mass extinction in Earth's history. The impact was so violent that it created a permanent scar in Earth's magnetic field over Antarctica. The concentration of iron-rich impact material creates a magnetic signature that's detectable from space. This buried crater affects how charged particles from space interact with this region, creating additional disruption to Antarctica's already anomalous magnetic environment. Scientists studying Earth's magnetic field have discovered that the South Atlantic anomaly is growing. The weakened region is expanding and the field strength continues to decrease. Some researchers believe this might be an early sign of a magnetic pole reversal, an event where Earth's north and south magnetic poles switch positions. This has happened many times in Earth's geological past, roughly every few 100,000 years on average. During the reversal process, which can take thousands of years, Earth's magnetic field becomes chaotic and weak, potentially exposing the surface to dangerous levels of cosmic radiation. If a reversal is beginning, Antarctica will be at the epicenter of this event, experiencing the most extreme magnetic field changes of anywhere on Earth. The continent that already breaks the rules might be about to break them even more dramatically. Antarctica is technically a desert. This statement confuses most people because they picture deserts as hot, sandy wastelands like the Sahara. But a desert is defined by precipitation, not temperature. Any region receiving less than 250 millimeters of annual precipitation is considered a desert. Antarctica receives almost no precipitation. Most of the continent gets less than 50 millimeters per year, making it the driest continent on Earth. The interior regions, the vast polar plateau far from the coast, receive virtually no precipitation at all. Some areas haven't seen measurable rainfall or snowfall in millions of years. This creates a profound paradox. Antarctica is covered in ice kilometers thick, yet it's one of the driest places on Earth. How is this possible? The ice covering Antarctica is not being replenished by snowfall, at least not in most areas. The ice is ancient, accumulated over millions of years during periods when Antarctica had more precipitation. Today's Antarctica is in a state of frozen stasis. The ice doesn't grow, much because there's little snowfall to add to it, but it also doesn't melt because temperatures are so low. The result is a landscape locked in time, covered by ice that fell as snow hundreds of thousands or millions of years ago. This ice is not part of the active water cycle in the way that Arctic ice or mountain glaciers are. It's more like a geological formation, a frozen archive of ancient climates that sits on the continent without significantly interacting with modern weather patterns. The dry valleys of Antarctica are the extreme expression of this desert environment. These valleys, located in the Transantarctic Mountains, are among the driest places on Earth. Some parts of the dry valleys have been ice-free for millions of years, despite being in Antarctica. They're swept clean by katabatic winds, fierce gravity-driven winds that roar down from the interior plateau at speeds exceeding 300 kilometers per hour. These winds are so strong and dry that they prevent snow from accumulating. Any moisture that does appear is instantly sublimated, turning directly from ice to water vapor without passing through a liquid phase. The result is a landscape that looks more like Mars than Earth. Bare rock, gravel, and sand, with mummified seal carcasses that died thousands of years ago, preserved perfectly by the dry, cold conditions. Scientists studying the dry valleys have found life clinging to existence in ways that challenge our understanding of biology. Microorganisms live inside rocks in tiny air pockets where they're protected from the brutal conditions outside. They're called endolithic organisms, and they survive on almost nothing. A tiny bit of moisture that occasionally seeps into the rock, a few photons of sunlight that penetrate the translucent stone, traces of minerals that can be metabolized. These organisms grow so slowly that a bacterial colony might take decades to double in size. They exist in a state of near suspended animation, barely alive by conventional standards, yet they persist and even reproduce. This is life at its absolute limit. clinging to a continent that seems designed to prevent life entirely. The lack of liquid water in most of Antarctica creates another fundamental difference from every other continent. Rivers don't really exist here. There are no permanent flowing streams in the interior. During the brief summer, when temperatures at the coast might rise just above freezing, small amounts of meltwater can form temporary streams that last for days or weeks before freezing again. But these are ephemeral, not the permanent river systems that shape landscapes on other continents. Antarctica has no equivalent of the Amazon, the Nile, the Mississippi, or any of the thousands of rivers that define other continental landscapes. Water doesn't flow here in liquid form for long enough to carve valleys, form deltas, or create the rich riparian ecosystems that rivers support everywhere else. The hydrological cycle that operates on every other continent is essentially frozen in place in Antarctica. Above Antarctica, in the stratosphere roughly 15 to 30 kilometers above the surface, something happens every year that doesn't happen anywhere else on Earth. The ozone layer, that critical shield protecting life from harmful ultraviolet radiation, develops a massive hole. This is not a metaphor. It's an actual region where ozone concentrations drop to a fraction of normal levels, creating a window through which dangerous UV radiation pours down onto the continent below. The Antarctic ozone hole forms every spring, September through November in the southern hemisphere, growing to cover an area larger than Antarctica itself before slowly healing as summer progresses. At its worst in the late 1990s and early 2000s, the ozone hole covered over 29 million square kilometers, an area larger than North America. What causes this phenomenon? The answer involves a complex interaction between human-made chemicals and Antarctica's unique atmospheric conditions. Chlorofluorocarbons, or CFCs, were widely used in refrigerants and aerosol sprays throughout the 20th century. These chemicals eventually drift up into the stratosphere, where ultraviolet light breaks them down, releasing chlorine atoms. Chlorine destroys ozone through a catalytic reaction, where a single chlorine atom can destroy thousands of ozone molecules before being removed from the stratosphere. This happens everywhere on Earth where CFCs reach the stratosphere. But the effects are dramatically amplified over Antarctica because of that continent's unique atmospheric dynamics. During the Antarctic winter, a polar vortex forms, a massive circular pattern of winds that isolates the air mass over Antarctica from the rest of the global atmosphere. Within this isolated air mass, temperatures drop to the lowest in Earth's atmosphere, sometimes reaching minus 90 degrees Celsius or colder. These extreme temperatures cause ice crystals to form in the stratosphere, creating polar stratospheric clouds. The surfaces of these ice crystals provide a place where chemical reactions can occur that wouldn't happen in the gas phase. When spring arrives and sunlight returns to Antarctica after months of winter darkness, this sunlight triggers the reactions that allow chlorine to destroy ozone. The combination of isolated air mass, extreme cold, polar stratospheric clouds, and returning sunlight creates a perfect storm of conditions that exist nowhere else on Earth. The result is that every spring, the ozone layer over Antarctica essentially disappears, at least in terms of providing meaningful protection from UV radiation. Anyone on the Antarctic surface during peak ozone depletion is exposed to UV levels that can cause sunburn in minutes and eye damage after brief exposure. This is why researchers in Antarctica during spring wear extreme sun protection even when temperatures are far below freezing. The sun in Antarctica during ozone hole conditions is more dangerous than the tropical sun at noon because there's virtually nothing blocking the most harmful wavelengths. Antarctica experiences UV radiation levels that are literally off the scale, designed for measuring sun exposure in normal environments. The international response to the ozone hole, the Montreal Protocol banning CFCs, has been successful in stopping the growth of the hole and beginning the healing process. Ozone levels over Antarctica are slowly recovering, though it will take decades for the hole to fully close. But the fact that this phenomenon occurred at all is revealing. Antarctica's atmosphere is so isolated and so extreme that it could be damaged in ways that don't affect atmospheric conditions over other continents. The rules governing atmospheric chemistry work differently here. Antarctica served as a warning of what human activity could do to Earth's atmosphere. Precisely because conditions there amplified and concentrated the effects in ways that made them visible before similar but less dramatic damage occurred elsewhere. Beneath Antarctica's ice sheet lies a landscape that nobody has ever seen: mountain ranges, valleys, plains, and coastlines that have been buried under kilometers of ice for millions of years. We know these features exist through sophisticated radar and seismic surveys that can penetrate ice and map the bedrock beneath. What these surveys reveal is astonishing. Antarctica's hidden landscape is as complex and dramatic as any other continent's geography. There are mountains under the ice that rival the Alps or Rockies in size. There are valleys deeper than the Grand Canyon. There are vast subglacial basins that extend below sea level, carved by ancient glaciers during times when the ice sheet was smaller or possibly by tectonic activity. The Gamburtsev mountain range is perhaps the most mysterious of these hidden features. Discovered by Soviet expeditions in the 1950s using seismic surveys, these mountains lie in the heart of East Antarctica, buried under 3 kilometers of ice. They stretch for roughly 1,200 kilometers and include peaks over 3,000 meters high relative to the surrounding bedrock. If these mountains were exposed, they would be comparable to the European Alps. But here's the mystery. The Gamburtsev Mountains should not exist. Mountain ranges are created by tectonic activity, by continental plates colliding and pushing up crustal rock. But the Gamburtsev Mountains are in the middle of a stable continental shield, far from any plate boundaries. The last major tectonic event in this region occurred over 500 million years ago. Any mountains formed then should have been eroded away long ago. Yet somehow these mountains persist, frozen under the ice, preserved when they should have weathered into hills or plains. Scientists have proposed various theories to explain the Gamburtsev Mountains. Perhaps they're the result of ancient tectonic activity we don't understand. Perhaps they've been preserved by the ice itself, which prevented normal erosion. Perhaps they're being actively uplifted by processes occurring deep in Earth's mantle beneath Antarctica. None of these explanations is fully satisfactory, and the Gamburtsev Mountains remain one of Antarctica's greatest geological mysteries. They're mountains that shouldn't exist, hidden under ice that shouldn't be so thick, on a continent that breaks every rule. The topography beneath Antarctica's ice sheet also reveals something disturbing about the ice sheet stability. Much of West Antarctica sits on bedrock that's below sea level. If the ice sheet were to collapse, this region wouldn't become land, it would become ocean. The West Antarctic ice sheet is essentially a marine ice sheet, grounded on bedrock below sea level but still above the ocean because the ice is so thick. This configuration is inherently unstable. If warm ocean water manages to get underneath the ice and melt it from below, the ice sheet can detach from the bedrock and potentially collapse rapidly. Scientists monitoring Antarctica have found evidence that this process might already be beginning. Glaciers in West Antarctica are accelerating their flow toward the ocean, suggesting they're losing contact with the bedrock beneath them. If this continues, the West Antarctic ice sheet could collapse within centuries or even decades, raising global sea levels by 3 to 5 meters and redrawing coastlines worldwide. The hidden lakes beneath the ice, mentioned earlier, are connected by an extensive network of subglacial rivers. These rivers flow beneath thousands of meters of ice, carving channels in the bedrock, transporting water from the interior of the continent toward the coasts. We can't see these rivers, but we can detect their effects. When water moves beneath an ice sheet, it changes how the ice above it flows. By measuring subtle changes in ice surface elevation and movement, scientists have mapped an extensive network of subglacial water flow. Some of these subglacial rivers are large, moving millions of cubic meters of water. They create a hidden hydrological system that operates in complete darkness, under unimaginable pressure, in conditions that exist nowhere else on any other continent. Antarctica is the best place on Earth to find meteorites, and this fact reveals another way the continent breaks the rules governing everywhere else. More meteorites have been found in Antarctica than in all other continents combined. The reason is simple but profound. Meteorites that fall on Antarctica land on ice or snow. The white surface makes the dark rocks easy to spot, But more importantly, the meteorites don't disappear. On other continents, a meteorite that falls will eventually be covered by soil, vegetation, or sediment. It will weather and erode. Within the centuries or millennia, it becomes indistinguishable from terrestrial rocks. But in Antarctica, meteorites are preserved. They sit on the surface of the ice or get buried in ice and then re-emerge as the ice flows and sublimates. Some meteorites found in Antarctica are over 1 million years old, having been locked in ice for that entire time before being naturally delivered back to the surface. The implications of this are staggering. Antarctica is acting as a natural meteorite collection machine, gathering samples from across the solar system and preserving them indefinitely. Scientists have found meteorites in Antarctica from Mars, from the Moon, from asteroids representing the earliest formation of the solar system. These rocks contain information about the history of our cosmic neighborhood that we can't get any other way. Some Antarctic meteorites have been dated to over 4.5 billion years old, making them older than any rock found on Earth's surface elsewhere. They're samples of the primordial material that formed the planets, preserved on a continent that functions like a planetary archive. But there's something stranger happening with Antarctic meteorites. They tend to concentrate in certain areas, blue ice regions where wind has scoured away surface snow to reveal older compressed ice, are particularly rich in meteorite finds. These concentration zones can contain thousands of meteorites in relatively small areas. The reason involves complex ice dynamics. As ice flows toward the coast, it sometimes encounters bedrock obstacles beneath the ice. The ice flow is blocked or deflected, and the combination of ice movement and surface sublimation causes meteorites to accumulate. It's as if Antarctica is actively sorting and organizing these cosmic rocks, creating natural museums of extraterrestrial material. Among the meteorites found in Antarctica are some that have sparked genuine controversy. ALH 84001, a meteorite, found in the Allen Hills region in 1984, created an international sensation when NASA scientists announced in 1996 that it might contain evidence of ancient Martian life. This potato-sized rock had been blasted off the surface of Mars by an asteroid impact roughly 17 million years ago. It wandered through space for millions of years before falling to Earth approximately 13,000 years ago, landing in Antarctica where it was preserved until human researchers found it. Analysis revealed structures inside the meteorite that some scientists interpreted as fossilized bacteria from Mars. The claim remains controversial and debated, but the fact that Antarctica delivered us a rock from Mars, potentially containing evidence of extraterrestrial life, demonstrates how this continent functions differently from anywhere else on Earth. There are also meteorites found in Antarctica that don't match any known type. These anomalous specimens have compositions or structures that don't fit into standard meteorite classifications. Some contain minerals that shouldn't exist based on our understanding of how the solar system formed. Others have isotopic ratios that suggest they came from regions of space very different from Earth's neighborhood. A few have characteristics suggesting they might be fragments of destroyed planets or moons, objects that no longer exist in our solar system. Antarctica has become a window into the broader cosmos, delivering samples from places we cannot reach and may never visit. For most of human history, Antarctica was not just unknown, but unreachable. The continent sits isolated by the Southern Ocean, surrounded by some of the most treacherous waters on the planet. The latitudes between 40 and 60 degrees south are known as the roaring 40s and screaming 60s because of the constant fierce westerly winds that circle the globe unimpeded by land. These winds generate massive waves, storms, that can sink modern ships and weather conditions that make navigation extremely dangerous. Before the development of steam-powered vessels and modern navigation technology, reaching Antarctica was nearly impossible. Even after Antarctic exploration began in earnest in the late 1800s and early 1900s, expeditions regularly ended in disaster, with ships crushed by ice, crews dying of scurvy and exposure, and explorers lost forever in the frozen wilderness. The early explorers who did reach Antarctica found a continent actively hostile to human presence. The famous race to reach the South Pole between Robert Falcon Scott and Roald Amundsen in 1911 to 1912 perfectly illustrates Antarctica's lethal nature. Amundsen reached the pole first and returned safely, but Scott and his entire party died on the return journey, their frozen bodies found months later just 18 kilometers from a supply depot that could have saved them. The diaries and letters found with Scott's body describe the brutal conditions, temperatures dropping to minus 40 degrees Celsius, blizzards that pinned them in their tent for days, frostbite destroying their feet, and ultimately starvation and hypothermia claiming them one by one. This was in summer, the most favorable season. Antarctica killed these experienced, well-equipped explorers despite their best efforts to survive. Even today, with modern technology, Antarctica remains dangerous in ways that no other continent matches. Research stations are equipped with extensive survival equipment, emergency supplies, and redundant systems because the environment will kill anyone who isn't constantly vigilant. Whiteout conditions can occur suddenly, making it impossible to see more than a few meters and causing complete spatial disorientation. People have gotten lost and frozen to death just meters from safety because they couldn't find their way back in the blinding whiteness. Metal equipment can shatter from cold. Vehicles break down in ways they don't in normal climates. Aircraft cannot fly during winter because it's too dangerous. For 6 months of the year, Antarctica is effectively cut off from the rest of the world, with no flights in or out and no possibility of rescue or resupply. The Antarctic Treaty, signed in 1959, designates Antarctica as a scientific preserve devoted to peace and science. National territorial claims are frozen, military activity is banned, and the continent is supposed to be used only for peaceful purposes, primarily scientific research. But this treaty also implicitly acknowledges that Antarctica cannot be colonized or exploited the way other continents have been. It's too hostile, too remote, too expensive to maintain a presence there. The treaty works not because nations are inherently cooperative, but because Antarctica itself makes traditional colonization impossible. No country can realistically establish the kind of permanent settlements and economic infrastructure that would allow them to effectively control Antarctic territory. The continent defeats any attempt at conventional occupation. There are parts of Antarctica where humans have never set foot. Vast regions of the interior are completely unexplored at ground level. We've mapped them with satellites and aircraft, but no person has ever walked there. These areas remain as pristine and untouched as they were millions of years ago, the only parts of Earth's landmass where this is true. Every other continent has been thoroughly explored and modified by human presence, but Antarctica contains entire mountain ranges, valleys, and regions larger than some European countries that remain virgin territory. This inaccessibility is another way Antarctica breaks the rules. In the 21st century, with our advanced technology and global reach, it seems impossible that there could be large land areas we simply cannot access. Yet Antarctica contains exactly that. Antarctica sounds different. This might seem like a minor detail, but it's profoundly unsettling once you understand what's happening. Ice makes noise. When it moves, cracks, compresses, or shifts, it creates sounds unlike anything else in nature. Scientists working in Antarctica report hearing these sounds constantly. Deep, booming noises as ice sheets shift and settle. High-pitched creaking and groaning as glaciers move. Sharp cracks like gunshots when ice fractures. Long, drawn-out rumbles as icebergs calve off glaciers and crash into the ocean. These are not occasional sounds. They're constant, creating an alien soundscape that never stops. But it's not just the sound of ice moving that's strange, it's also the absence of other sounds. Antarctica is the quietest place on Earth in terms of biological noise. There are no bird songs in the interior, no insect buzzes, no animal calls, no rustling of vegetation and wind. Even the wind itself sounds different because there are no trees or buildings to create the familiar whooshing or howling we hear elsewhere. The wind in Antarctica often produces a strange whistling or moaning sound as it moves across ice and rock surfaces. The overall effect is deeply unnerving. Human brains expect to hear certain ambient sounds. We're evolved to process background noise from living things, from wind and trees, from flowing water. Antarctica provides none of these familiar audio cues, creating a sensory environment that feels wrong on a deep, instinctive level. Scientists have deployed underwater microphones in the Southern Ocean around Antarctica and recorded sounds that don't match any known source. Strange low-frequency booms and pulses that some researchers call bioduck sounds or bloops. These sounds are biological in nature, produced by living creatures, but their exact source remains unidentified. They might be from whales, possibly an unknown species or a known species producing vocalizations we haven't documented before. Or they might be from some other large marine animal. The Southern Ocean around Antarctica is so poorly explored that entirely new large species are periodically discovered. In 2007, a colossal squid, the largest invertebrate ever found, was captured in Antarctic waters. If something that large can remain unknown until recently, what else might be living in those deep, cold waters making sounds we can't explain? The ice itself seems to communicate across vast distances through sound. Glaciologists have discovered that ice sheets can create vibrations that travel for hundreds of kilometers, like a very slow, very low frequency form of communication. When a large section of ice breaks off from a glacier, the event creates seismic waves that can be detected across the entire continent. The ice sheet seems to respond to these signals, with distant regions showing increased activity after major calving events. It's as if the ice sheet is a single, continent-sized entity that reacts to damage or stress in one area by adjusting its behavior elsewhere. This probably isn't conscious communication, but it's a level of interconnected behavior that scientists didn't expect to find in what should be an inert, geologically dead system. There have also been reports of auditory phenomena that seem to have psychological effects on people working in Antarctica. The haunting of Antarctica is well documented in explorer journals and research station logs. People report hearing voices when no one is there, sounds of machinery that isn't running, music from unknown sources. These experiences are particularly common during the long Antarctic winter when darkness is continuous and isolation is complete. The phenomenon is usually attributed to psychological factors, the stress of isolation, sensory deprivation, and cabin fever. But the consistency of reports across different expeditions and eras is striking. It's possible that the extreme environment, including factors like electromagnetic anomalies, atmospheric pressure variations, or infrasound from ice movement, creates conditions that affect human perception in ways we don't fully understand. Antarctica doesn't just look and feel different, it sounds different in ways that can alter consciousness itself. Locked within Antarctica's ice is the most complete record of Earth's climate history available anywhere on the planet. Every year, snow falls on the ice sheet and is gradually compressed into ice, trapping tiny bubbles of ancient atmosphere. These bubbles are time capsules containing air from when the snow fell. By drilling deep into the ice and extracting cores, scientists can analyze these trapped air bubbles and determine what Earth's atmosphere was like hundreds of thousands of years ago. The deepest ice cores retrieved from Antarctica contain ice over 800,000 years old, providing a direct sample of air from a time when Homo sapiens didn't exist yet. What this ice reveals is both fascinating and terrifying. The atmospheric carbon dioxide levels recorded in ice cores show a clear pattern of variation corresponding to ice ages and warm periods. During ice ages, carbon dioxide drops to around 180 parts per million. During warm interglacial periods, it rises to around 280 parts per million. This cycle has repeated with remarkable regularity for hundreds of thousands of years. But here's what's disturbing. Current atmospheric carbon dioxide levels are over 420 parts per million, far higher than anything recorded in these ice cores. We've pushed Earth's atmosphere into territory it hasn't been in for at least 800,000 years, possibly much longer. Antarctica's ice archive is telling us that what we're doing to the planet is unprecedented in recent geological history. The ice cores also contain layers of volcanic ash, cosmic dust, and other particles that mark specific events in Earth's history. Scientists can identify major volcanic eruptions by finding spikes of volcanic particles in specific ice layers. They can track changes in solar activity by measuring isotopes created by cosmic rays. They can even detect human influence on the atmosphere going back centuries. Lead pollution from Roman mining operations shows up in Antarctic ice from 2,000 years ago. Industrial pollution from the coal burning of the Industrial Revolution appears in ice layers from the 1800s. Nuclear weapons testing in the 1950s and 60s left clear signatures of radioactive isotopes. Antarctica has been recording human impacts on the planet long before we realized we were having such impacts. But the ice cores reveal something even more unsettling about Antarctica itself. Analysis of the oldest ice shows that the Antarctic ice sheet is far more ancient than we previously thought. Ice at the very bottom of the ice sheet, where it contacts bedrock, can be over 1 million years old in some locations. This means Antarctica has been frozen for at least that long, possibly much longer. But geological evidence suggests that Antarctica wasn't always frozen. Fossils found in Antarctic rocks show that the continent once supported forests with trees, ferns, and diverse plant life. Coal deposits in the Transantarctic Mountains contain fossilized plants from tropical or temperate forests. This means that at some point in the distant past, Antarctica had a completely different climate. The transition from forested continent to frozen wasteland happened relatively recently in geological terms, probably beginning around 34 million years ago. Something changed in Earth's climate system that caused Antarctica to freeze. The leading theory involves the opening of the Drake Passage, the ocean gap between Antarctica and South America. When this passage opened, it allowed the formation of the Antarctic Circumpolar Current, a massive ocean current that circles Antarctica and effectively isolates it from warmer waters to the north. This current acts like a refrigerator, keeping warm water away from the continent and allowing it to cool dramatically. Once this cooling process started, it became self-reinforcing. Ice formed, reflected more sunlight, causing more cooling, which formed more ice. Antarctica entered a feedback loop that ultimately encased the entire continent in ice kilometers thick. What's frightening is that this process could theoretically work in reverse. If Antarctica's ice sheet begins to melt significantly, it could trigger feedback loops in the opposite direction. Less ice means less sunlight reflected, which means more warming, which melts more ice. The Antarctic ice sheet is not a stable feature. It's a system balanced on a knife's edge, maintained by specific conditions that currently exist but could change. The geological record shows that ice sheets can grow and shrink with remarkable speed once feedback. Loops are triggered. Antarctica could transform from frozen continent back to temperate land within thousands of years if conditions change. Given human-induced climate change, the possibility that we might witness the beginning of this transformation is genuinely possible. Life in Antarctica exists in defiance of everything we thought we knew about biological limits. The continent hosts ecosystems that challenge fundamental assumptions about what life requires to survive. We've already mentioned the endolithic microorganisms living inside rocks in the dry valleys, but the biological strangeness of Antarctica goes far beyond that. In the coastal regions and surrounding ocean, life has adapted to conditions that should be lethal. Fish in Antarctic waters have evolved antifreeze proteins in their blood that prevent ice crystals from forming even when water temperatures drop below the normal freezing point of fish blood. These proteins are so effective that some Antarctic fish can survive in water that's minus 2 degrees Celsius, temperatures that would instantly freeze the blood of fish from any other ocean. The Antarctic midge, Belgica antarctica, is the largest purely terrestrial animal on the Antarctic continent. It's only about 6 millimeters long, a tiny flightless fly that lives its entire 2-year life cycle on the Antarctic Peninsula. What makes this insect remarkable is its ability to survive conditions that would kill almost any other insect on Earth. It can withstand complete dehydration, losing 70% of its body water, and remaining in suspended animation for months before rehydrating and continuing its life cycle. It can survive being frozen solid with ice crystals forming throughout its body tissues, and then thaw out and continue living as if nothing happened. Its genome has been completely resequenced, and scientists discovered it has the smallest insect genome ever found, having apparently lost genes for many functions that others insects need. It's stripped down to the bare minimum necessary for life, optimized for survival in the harshest terrestrial environment on Earth. In the subglacial lakes buried under kilometers of ice, life has found ways to exist that border on the impossible. These lakes have been isolated from Earth's surface for hundreds of thousands or even millions of years. They receive no sunlight, no fresh organic material, no connection to the surface biosphere, yet they contain ecosystems. Bacteria and other microorganisms have been found living in these lakes, surviving on chemical energy derived from rocks and minerals. This is chemosynthetic life, similar to the ecosystems found around deep-sea hydrothermal vents, but even more isolated and extreme. These organisms might represent one of the most ancient forms of life on Earth, following metabolic pathways that date back billions of years to when Earth's atmosphere had no oxygen and all life was chemosynthetic. The discovery of life in Antarctica's subglacial lakes has profound implications for astrobiology, the search for life on other planets and moons. Jupiter's moon Europa and Saturn's moon Enceladus both have oceans of liquid water buried under thick ice shells, conditions remarkably similar to Antarctica's subglacial lakes. If life can exist in Lake Vostok, it could potentially exist in Europa's ocean. Antarctica is serving as a test case for whether life can survive in the ice-covered worlds common in the outer solar system. The fact that life has found ways to survive in such extreme isolation suggests that life might be far more common in the universe than we previously thought, able to persist in environments we once considered completely sterile. But perhaps the most biologically disturbing aspect of Antarctica is what's called the Antarctic paradox. Despite being one of the most extreme environments on Earth, the Southern Ocean surrounding Antarctica is one of the most productive marine ecosystems on the planet. During the Antarctic summer, phytoplankton blooms turn vast areas of the ocean green. These microscopic plants support massive populations of krill, small shrimp-like crustaceans that form the base of the Antarctic food chain. Krill populations in the Southern Ocean are so enormous that they may constitute the largest animal biomass on Earth. Everything else in the Antarctic marine ecosystem, fish, seals, penguins, whales, depends on krill, and krill depend on the unique conditions created by Antarctica's ice and currents. The ice itself is crucial to this productivity. As sea ice forms during winter, it excludes salt from the ice structure, creating pockets of super salty brine. This brine sinks, driving ocean circulation. When spring arrives and the sea ice melts, it releases fresh water on the surface, creating a stable layer that traps nutrients near the surface where phytoplankton can access them. The melting ice also releases iron and other nutrients that had been incorporated into the ice, providing fertilizer for phytoplankton blooms. Without Antarctica's seasonal ice cycle, the Southern Ocean would be far less productive. The continent that seems hostile to life is actually supporting one of Earth's richest ecosystems through mechanisms that only work in extreme cold. Antarctica is the only continent with no native human population, no indigenous people, and no clear ownership. The Antarctic Treaty suspended all territorial claims, but those claims still exist in the background, creating a unique legal and political situation unlike anywhere else on Earth. 7 countries maintain territorial claims in Antarctica: Argentina, Australia, Chile, France, New Zealand, Norway, and the United Kingdom. Some of these claims overlap, creating disputed zones where multiple countries claim the same territory. The United States and Russia maintain a basis of claim without actually making formal claims, reserving the right to claim territory in the future. Most other nations don't recognize any territorial claims in Antarctica and view the continent as international territory. This ambiguous situation works only because Antarctica is too difficult and expensive to exploit economically. There are mineral resources in Antarctica. Geological surveys suggest substantial deposits of iron ore, coal, and potentially oil and natural gas. But extracting these resources would be enormously expensive, given the extreme conditions and the remote location. Currently, the Antarctic Treaty prohibits mining and mineral exploitation, but the treaty could be modified if economic conditions change. If new technologies make Antarctic resource extraction profitable, or if resources become scarce enough elsewhere to make Antarctic resources worth the cost, the current international cooperation could collapse. Antarctica might become a source of conflict rather than cooperation. There's also the question of what happens if Antarctica becomes more habitable due to climate change. If global temperatures continue rising, parts of Antarctica might become ice-free and potentially suitable for agriculture or settlement within centuries. Who would own this newly habitable land? Would the old territorial claims be reactivated? Would there be a land rush as nations try to establish presence and claim territory before others? The Antarctic Treaty doesn't clearly address this scenario, and the potential for conflict is real. Antarctica might be the source of future territorial disputes that dwarf anything in current international politics. The strategic importance of Antarctica is also unclear and potentially disturbing. The continent offers unique advantages for certain military and intelligence operations. Its isolated location and extreme environment make it an ideal place for activities that countries want to keep secret. The Antarctic Treaty prohibits military bases and weapons testing, but monitoring compliance is difficult. The interior of Antarctica is so remote and inaccessible that clandestine operations could potentially occur without detection. During the Cold War, both the United States and Soviet Union maintained extensive operations in Antarctica, officially for scientific purposes, but the full extent of what they were doing remains partially classified even today. There are also questions about what lies beneath the ice that haven't been fully answered. Ground-penetrating radar and seismic surveys have mapped much of the bedrock beneath Antarctica's ice, but these surveys have also detected anomalies that don't have clear explanations: unusual magnetic signatures, unexpected voids in the ice, and structures that might be natural geological formations or might be something else. Some of these anomalies have sparked speculation about everything from secret bases to crashed UFOs to lost ancient civilizations. While most of these theories are almost certainly nonsense, the fact remains that there are large areas under the Antarctic ice that we've never directly observed and may never be able to access. Antarctica holds secrets, and some of them might remain secret forever simply because the environment prevents investigation. Antarctica's future is perhaps the greatest uncertainty in climate science. The continent holds enough ice to raise global sea levels by 58 meters if it all melted, but predicting when and how much melting will occur is extraordinarily difficult. Ice sheet dynamics are complex, involving factors that scientists are only beginning to understand. The West Antarctic ice sheet is particularly concerning because much of it sits on bedrock below sea level, making it vulnerable to a process called marine ice sheet instability. If warm ocean water gets underneath the ice sheet and begins melting it from below, the ice could detach from the bedrock and slide into the ocean relatively quickly. Some glaciers in West Antarctica are already showing signs of instability. The Thwaites Glacier, nicknamed the Doomsday Glacier, is one of the fastest changing areas in Antarctica. It's losing about 50 billion tons of ice per year, and the rate is accelerating. The glacier is held back by an ice shelf, a floating platform of ice that acts like a cork in a bottle, slowing the glacier's flow into the ocean. But this ice shelf is weakening and could collapse within years or decades. If it does, the Thwaites Glacier would accelerate dramatically, potentially triggering the collapse of a much larger region of the West Antarctic ice sheet. This could raise global sea levels by over 3 meters, drowning coastal cities worldwide and displacing hundreds of millions of people. But predicting the timeline for this potential catastrophe is nearly impossible. Ice sheets can remain stable for centuries and then collapse rapidly once certain thresholds are crossed. Alternatively, they can reach what looks like a tipping point and then stabilize again, through mechanisms we don't fully understand. Antarctica is a system with countless feedback loops, both positive and negative, and we don't know which feedbacks will dominate as temperatures continue to rise. It's possible that Antarctica's ice sheet could remain largely stable for centuries, despite continued warming. It's also possible that we're on the verge of irreversible collapse that will transform the continent and the entire planet within our lifetimes. The uncertainty itself is disturbing because it means we can't plan effectively for what's coming. There's also the question of what happens if Antarctica does begin to melt significantly. The continent under the ice is not the flat plain many people imagine. It's a complex landscape with mountains, valleys, and basins. As ice melts, some areas would become exposed land, but other areas would flood, becoming shallow seas. The coastline of Antarctica would change dramatically, creating new bays, peninsulas, and islands. Over thousands of years, if all the ice melted, Antarctica might look like a continent of islands and narrow land bridges rather than a single unified landmass. The biological colonization of these newly exposed lands would be fascinating to observe. Plants and animals would gradually spread from the coastal regions that already support limited life, adapting to conditions that would still be cold by global standards, but hospitable compared to current Antarctic conditions. If humans are still around thousands of years in the future, a partially or fully melted Antarctica might become valuable real estate. The continent is rich in mineral resources, has vast amounts of fresh water locked in remaining ice, and would have unique ecosystems found nowhere else. It might become the site of major cities, resource extraction operations, and scientific research centers. The continent that was completely uninhabitable for all of human history might become home to millions of people. This transformation would represent one of the most dramatic changes to Earth's geography since the continents reached their current positions. Antarctica would no longer be the exception to the rules governing other continents. It would become just another landmass, subject to human exploitation and alteration like everywhere else. But there's another possibility that's even more unsettling. What if the changes to Antarctica trigger climate feedback loops that affect the entire planet in ways we can't predict? The melting of Antarctic ice would release enormous amounts of fresh water into the Southern Ocean, potentially disrupting ocean currents that regulate global climate. The Antarctic circumpolar current could weaken or shift, altering weather patterns worldwide. The exposure of dark rock currently under ice would reduce Earth's albedo, causing the planet to absorb more solar radiation and warm even faster. The destabilization of methane hydrates trapped in Antarctic sediments could release large quantities of greenhouse gases. Antarctica's transformation might not be a local event. It could trigger a cascade of changes that fundamentally alter Earth's climate system, potentially making the planet less hospitable for human civilization everywhere. There's something about Antarctica that affects human psychology in ways that are difficult to articulate, but impossible to ignore. People who have spent extended periods in Antarctica often describe the experience as transformative, but not always in positive ways. The isolation, the extreme environment, the constant awareness that you're living in a place actively trying to kill you, all of this creates psychological pressure that can break even strong minds. The phenomenon known as Antarctic stare has been documented since the early exploration era. People who have been in Antarctica too long develop a vacant thousand-yard stare, as if they're looking at something beyond the horizon that nobody else can see. Winter over syndrome is a recognized psychological condition affecting people who spend the Antarctic winter at research stations. During the winter, the sun doesn't rise for months. The temperature drops to levels where going outside is genuinely dangerous. Flights in or out are impossible. You're trapped with the same small group of people in a tiny island of warmth and light surrounded by thousands of kilometers of deadly frozen darkness. People experiencing winter over syndrome report symptoms including depression, irritability, cognitive impairment, sleep disturbances, and in severe cases, hallucinations and paranoia. Even with careful psychological screening and support, the condition affects most people who winter over in Antarctica to some degree. There are also reports of something more subtle and more disturbing. People describe Antarctica as feeling wrong in a way they can't quite explain. Not just hostile or dangerous, but somehow fundamentally alien. The landscape doesn't look like anywhere else on Earth. The colors are wrong, too white, too blue, lacking the earth tones that human vision evolved to process. The scale is wrong, with no reference points to judge distances, causing objects to appear much closer or farther than they actually are. The silence is wrong, missing the constant low-level noise of life that exists everywhere else. Time feels different with the endless daylight of summer or endless darkness of winter, removing the normal daily cycle that regulates human biology and psychology. Antarctica doesn't feel like a place that belongs on the same planet as the rest of our world. This psychological impact might explain some of the stranger reports from Antarctic expeditions. There are documented cases of explorers experiencing what can only be described as altered states of consciousness. Ernest Shackleton, during his Imperial Trans-Antarctic expedition, reported that he and his men felt the presence of an additional person with them during their desperate trek across South Georgia Island. All three men independently reported feeling this presence, describing it as benevolent and comforting. This phenomenon, now called the third man factor, has been reported in many extreme survival situations, but it seems particularly common in Antarctic accounts. Whether it's a psychological coping mechanism, a hallucination caused by stress and exhaustion, or something genuinely anomalous about Antarctica's environment remains unclear. The cumulative effect of Antarctica on human consciousness might be revealing something important about the limits of human adaptability. We can survive in Antarctica with modern technology, but we cannot truly thrive there. Our psychology is not equipped for the continent's extremes. Unlike every other environment humans have colonized, from Arctic tundra to tropical rainforests to high-altitude plateaus, Antarctica remains fundamentally incompatible with human neurology. We might be able to extract resources, conduct research, and maintain temporary presences, but we cannot make Antarctica home in any meaningful sense. The continent defeats not just our bodies but our minds, refusing to be incorporated into the human story the way every other continent has been. After examining all of these strange characteristics, we can finally identify the fundamental rule that Antarctica breaks. Every other continent on Earth has been shaped by life. Life colonizes, modifies, and ultimately transforms every environment it encounters. Bacteria break down rocks into soil. Plants hold soil in place and modify local climates. Animals disturb the land, creating trails, burrows, and clearings. Over millions of years, life transforms geology, creating sediments, coal, oil, and carbonate rocks. The interaction between geology and biology is so thorough on other continents that they're inseparable. You cannot understand the landscape of Africa, Asia, or South America without understanding the role that life has played in shaping it. Antarctica is different. Life exists there, but it doesn't dominate. The continent is shaped primarily by physical forces, ice, wind, temperature, with biology playing only a minor role. This makes Antarctica more like a moon or planet than an Earth continent. On Mars, Venus, or the moons of Jupiter, geology operates without significant biological influence. Landscapes are shaped entirely by physical processes, impacts, volcanism, erosion, tectonics. Antarctica is the only place on Earth that operates under these rules. It's a window into what planets look like before life takes over, or after life has been scrubbed away. It's showing us an alternative way for a world to exist, one where physics and chemistry rule absolutely without the moderating influence of biology. This is why Antarctica feels so alien. We're evolved to read landscapes shaped by life. We instinctively look for signs of vegetation, water sources, animal, trails, places that might offer food or shelter. Our pattern recognition is tuned to detect the signatures that life leaves on the environment. But in Antarctica, especially in the interior, those signatures are absent. The landscape is pure geology, and our brains struggle to process it because we have no evolutionary context for such places. We might as well be standing on Mars. The cognitive dissonance is profound and unsettling. The rule that Antarctica breaks is this: every other continent is a biological entity as much as a geological one. They're living systems where rock, water, air, and life interact to create ecosystems, modify climates, and shape evolution. Antarctica is a geological system with life clinging to the margins, surviving but not thriving, adapted but not dominant. It's the exception that proves how unusual Earth really is. Our planet is defined by the interaction between geology and biology. Remove the biology, and you get something like Antarctica, a frozen desert more similar to dead worlds in space than to the living continents that make up the rest of Earth. This has profound implications for how we think about planets and the search for life in the universe. If Antarctica can exist on Earth, a planet teeming with life, as a biological dead zone, then planets with local pockets of life, surrounded by sterile wastelands, might be common. We shouldn't expect alien worlds to be uniformly covered in life the way most of Earth is. They might be more like Earth with Antarctica scaled up, with small regions where conditions allow life to persist, surrounded by vast areas where physical processes dominate. Antarctica is teaching us that even on a living world, dead zones are not only possible, but perhaps inevitable, places where conditions are so extreme that biology cannot establish the feedback loops necessary to transform and dominate the environment. The future of Antarctica will determine whether this rule violation is temporary or permanent. If climate change causes significant melting, life will colonize the newly exposed land, and Antarctica might eventually become a biological continent like the others, shaped by the interaction of life and geology. But if the ice sheet persists or even grows due to complex climate feedbacks we don't fully understand, Antarctica will remain the exception, the continent where life never achieved dominance, where physical processes rule supreme. Either way, Antarctica will continue to be the most mysterious and important continent for understanding both our planet and potentially other worlds in the universe. What Antarctica ultimately represents is a challenge to our assumptions about how worlds should work. We assume that life, once it appears, will spread and dominate every available niche. We assume that biology will modify geology to suit itself. We assume that given enough time, life will transform hostile environments into habitable ones. Antarctica proves all of these. Assumptions wrong. For millions of years, life has been present on this continent, yet it remains hostile, frozen, dominated by physical forces. Life has not transformed Antarctica. Antarctica has confined life to tiny refuges where it survives but does not conquer. This is a different model for how life and environment interact, and it suggests that Earth's usual pattern of biological dominance is not inevitable. Antarctica stands as proof that even on a living world, there can be places where the rules of life don't apply, where physics wins and biology loses, where the planet remains fundamentally alien despite being surrounded by life. That is the rule Antarctica breaks, and it's perhaps the most important rule of all.